Oh, 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 oh. There we go. This is the right one? Yes. Copy. Close. Hey Blake, how are you? Oh, hang on just a second. There we go. Oh man, it's cold today. How are things in Pueblo? If that's where you guys are, I'm up in the Springs and it is freaking cold. So, or at least it feels cold. I don't know. Let's find out whether. Yeah, it's cold. About in Pueblo. Sometimes this is set to Pueblo and sometimes it's here. Yeah, it sucks down there too. Got it. Yeah. It's been chilly all day today. Yeah, I'll bet. So, on campus in particular, I've only been to the dorms a couple times, depending where you are. So, some of those are much older than the others. So, it just depends. East, yeah. Oh, really? It's been snowing, huh? Wow. Yeah, I don't think we get any snow here in the Springs, or at least not that I noticed. It was really misty this morning and stuff, but I didn't see any snow. I'm sure there's about half an inch of ice on my car. Unfortunately, I'm not going anywhere today. Yeah, Aurora? Yeah, no, I'm not surprised up in Denver. So, yeah, that is interesting. So, if you got snow there but not on campus, that's really interesting. So, no, I hear it's supposed to be like really gnarly this weekend. Let's see. Yeah, up here Sunday, snow in the Springs. What about Pueblo? You guys supposed to get snow? Yeah, same thing. Oh my gosh, look how cold it's supposed to be. Ooh. Brr, man. So how much precip? It's all in the morning too, huh? Yeah, interesting. So how about up here? Yeah, all in the morning. So probably Saturday night too. Oh my gosh, look how cold that is though, man. So, yeah. Well, yeah, depending on what building you're in, that's good or bad. Yeah. So, oh, man. All right, we'll get started in a minute here. Oh my gosh, you have softball on that? I don't know about that, man. If it's like 4 degrees out. So, yeah. Well, what is it? I mean, shoot, spring training pitchers report, like what, 3 weeks? 4 weeks? Something like that. Yeah, I guess we're getting done with football now. We still got March Madness coming up. And then, but yeah, oh my gosh, that is way too cold. So I think I'd find a reason not to be there that day. So that's crazy. Oh, just got this weird cold snap going on right now. So Uh, oh, okay. So go to here. I'll show you. That's a good question. So the question is, where do I look to see which quizzes? I guess the only way that I would do that is in your student view here. Um, so you got your three bars up here. Click on that, and then remember your quizzes are on the assignments here, and so these are the quizzes that you have to do. There's no way to kind of like preview each one of these, like in terms of what ones you would want to skip, I guess. But and if you have already taken them, you know what? Actually, I guess I haven't updated the quiz grades. So because I have to take the quiz grades and then punch them into Blackboard. So the other way it would be, well, I mean, it'll still show up here as you took it. So if you took one, obviously you don't want points for that one. But at the same point in time, if you're trying to avoid a particular topic or something like that, like if there's one that's hard, course modules over here, these are broken down by the chapters, all right? And so this is your oranges, these are your reds. This is purple, dark blue, and then light blue. And so, if there's a chapter in here or if there are a bunch of problems that were kind of giving you, difficulties, hang on to it. And you don't have to tell me right away, too. So, I mean, you can email me in 6 weeks or so. I don't care. That's fine. And so, if you want my recommendations about which ones to skip, Chapter 5 is a pain, and then I'd say Chapters 10, 11, and 12. These aren't that hard. They're just really time-consuming, okay? Some people struggle with 7 as well, and so any of those would be good. Some people, they just go forward and then work their way back. Some people start back and work their way forward, so whatever works, But yeah, and then if you email me and say, okay, I want this one off, you'll get an email back from me that says, okay, got it, thanks, and then you'll see the points pop up in Blackboard. So if you've done that in the past and you haven't gotten an email me and it hasn't showed up in Blackboard, it's probably because it got buried in my email somewhere. And I'm sorry, guys, I get like on bad days, I'll get 100 emails. All right, so if it escapes too far down, the chain there, then yeah, sometimes I just forget about it. So just keep on me about it, and totally fine. Don't feel like you're bothering me. Yeah, okay, I'll take a look at it. See, and that's the one. Like if it was from last week, I think I got those all cleaned up on Saturday and Sunday this week. So just ping me again. It's fine. I trust you. Yeah. Oh dang! What? So that's okay. Yeah, no worries. And sorry about that. Again, yeah, just sometimes like with 3 different classes where we're doing stuff like this, sometimes, yeah, if you get a receipt from me, then yes, it's done. So sorry. But yeah, no, I'm still good for it. Anyone see the video of Tom Brady after the Super Bowl parade today? No, not yet. What was going on with that? I'll have to go check it out. I'm sure it's all over the YouTube. I can, yeah, I'll try. So just make sure, because especially if you're in both classes, that I'm getting them in the right ones. So yeah. Yeah, no, apologies about that. It's just, it is kind of hard to keep on top of it. So, and I'm not perfect by any means. So, but I am good for it. So don't worry about that. Yeah, I don't know what a Super Bowl one you're talking about. There. Yeah, no worries, dude. No worries. So, yeah. Yeah, no, I saw some other things like, he's going to be the first quarterback to win a Super Bowl at age 50. So, oh, the trophy? Oh, he threw across the water to Gronk. Man, I feel bad for Gronk. He's going to be one of those guys, like, I mean, because what is he? He's like 36, something like that. I don't even know. Man, I hope he turns out okay, man, but I am afraid that guy's going to be a vegetable by the time he's 45. So I'm just, yeah. I mean, the way he plays is just, I mean, I hope his skull is built for it, man. I really do, because I think he's fun to watch, but yeah. So, there's a Gronk catch football kind of thing going on. Yeah. So, oh, really? Yeah, okay, got it. All right, cool stuff. All right, so we need a trivia topic today. There's not very many of us here, so, I think you've got a good shot at getting something for free today. And that just happens with this class, so, people get at a point in time where they feel pretty good, or they check it out the live stream later. And so if you're here, appreciate that. And we'll pick something today. Or we'll just do general trivia or something. We've already done NFL trivia in this class. We already did football, didn't we? So, and, obviously it's kind of like, we're good, because the season's over. Although the draft is coming up, and I know some people get really excited about that. But I'm not a 365, 12-month kind of football guy. This is kind of, movies. Yeah, movies is a good one. Let's do movies. So, I don't think we've done that one yet. You got to get specific on that one, though. What kind of movies? Are we doing, like, comedies, or are we doing, like, 80s movies, or what? So, movie quotes. Okay. Yeah, we'll do movie quotes. Yeah, I like that one. So that's a good one. We'll do that here in a minute. But right now, let's dive into Alex a little bit, because I did promise to show you two things today that are important. So I still haven't gotten. Let's see if I get one here. Nope, I still haven't gotten a knowledge check, and that might be because it's an instructor account, but I don't know. So, but I do have two of these guys left. All right, and so mean, median, mode, and comparisons. I think I covered that one pretty well the other day. We'll murder that one off here real quick, and then we'll dive into Chebyshev. All right, because this one is probably this is the most advanced problem in all the oranges, and it's the one that I definitely get the most questions on. All right, and so we'll go through it in detail today. Let's kill this one off, because I just got to get one more of these right in here. All right, so blah, 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 there's our data. Okay, and just remember with these, it's going to ask you a series of logical questions, and just remember that with each one of these, A, B, C, and D, there's kind of rules of thumb that you want to follow. So this one, for these data, which measure a central tendency take on more than one value. Mean and median will only ever have one value, all right? So you can't have two means, you can't have two medians in data, so it's always a question of mode. So how many modes are there? Let's see, 1, 2, 3, 4, 5 twos, 1, 2, 3 threes, 1, 2, 1, 2, 3. So it looks like we only have one mode here, so it's 5 twos. And so this one is asking us more than one value, so we only have one mode, so no, none of these right here. And then supposed measurement 17, the largest, so this one right here we're replaced by 40. In this case, our mean would change. So whenever you tinker with any of the data, your mean always changes. So honestly, on part B here, you're always going to answer that one. All right, the question is, does our mean or our mode change, or a median or our mode change? Well, our mode's way down here, so it's not affected by it. Our median, though, would not change either, because notice that we're not changing the number of observations in the data set, so it'd still be our middle number. With 18, it would be between 9 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Be right between 5 and 5, so it'd be 5. And so, yeah, changing this number wouldn't change our median at all. Okay, and sometimes... yeah, so I don't think you ever check that one on this part B. The question is on part C, you do check it sometimes, because suppose we're starting with the original data set, we remove that largest value. So this one, we're just going to kill off this 17, okay? And so, of course, our mean is going to change. Our median would not change, okay? Because think about that. Our median right now is right here between 5 and 5. If we murdered off this 17, our median would be the middle value, so it would go from being here to being right on 5, and since it already was 5, that one's not going to change either. Our mode is way down here, so it doesn't change, and so this one, it's just the mean. This is kind of rare, but sometimes they do throw this one at you. And last but not least, which of the following best describes the distribution of the original data? Remember, the tail always points towards the skew. This one's positively skewed because the tail points towards the higher numbers on the number line here, and so it has a positive skew. So just remember, your tail always points towards the skew. Check. There we go. Donezo. All right, let's do Chebyshev. here. And so this is a two-part problem, so we'll do one or two of them, and then we will do some trivia, and then we will well, actually, screw that, let's do some trivia right off the bat here. So let me go find movie trivia, and let me see if I can find a good one. Wow, I'd be better if I could actually spell that correct. And so for free quiz or homework today, or a free quiz, that's right, this class doesn't have any homework assignments. No, I don't want cookies. Get off my site. Never mind, I gotta find a new site. There we go. Oh, so some of these are pretty easy. Oh, this one's not giving me answers, though. I bet you I can answer a bunch of these. Oh, yeah. Alright, so no, we're not going to do those. Let's do another one. Let's try another quiz here. Oh, okay. Yeah, no, we got a ton of these. This is a great site. Alright, I found tons of them. Let's see if I can find something that's a little bit... I don't know. Let's look for something that's a little bit older here. Oh, you would know that one. Let's see. Let me see. Oh, come on. You all know who was going to be back. Let me see. Let me find something here. You all know who had the problem that they had a radio into Houston. I get that. Let's try something else. You all know who said, "Say hello to my little friend." Here's a great one. Okay, so yeah, here you go. Keep your friends close, but your enemies closer. Who said it? Or actually, just give me the movie. Keep your friends close, but your enemies closer. This is a good one. Okay, so if you're a little bit of a movie buff, you should know this. So you keep your friends close, but you keep your enemies closer. I just watched this not too long ago. So excellent movie. And if you Google it, you might get multiple answers on it. So, oh, you got it, Blake. It's The Godfather 2. Yeah, I knew someone was going to say The Godfather. All right, but it's actually part 2. Yes, absolutely. So, that was excellent. Yes, it's Michael Corleone. It's not Michael Corleone. Oh, yeah, Corleone. Actually, it's got an E at the end of it, doesn't it? There you go. Yeah. So, all right, good job. No, but Blake, you beat him to it because I asked for the movie. I don't really need who said it. So the movie is, of course, The Godfather Part 2, which, in my opinion, is the better of the two, but not everybody agrees with me on that. So we'll do another one here in just a couple of minutes. But let's jump in here and do some Chebyshev, all right? So Chebyshev's theorem and the empirical rule. So the explanation on this problem is a pain because you're going to get multiple explanations depending on which problem you get, okay? So, but what it is it's going to give you, sometimes these are just 2 parts, sometimes they're 4 part, or maybe there's ones that have 3 in there as well. But these are questions where you have to figure out the answers, but it's actually asking you 2 different things here that are based upon the same principle, but they are fundamentally different in terms of how you do them. And so the top 2 questions in here are always going to be on Chebyshev's theorem, which is this guy right here. And then these bottom 2 on here, you can tell that they're going to be different because rather than saying anything about Chebyshev, it'll say suppose the distribution is bell-shaped. And so both of these questions, what they do is they deal with, like, what's the probability of finding any given random observation within a data set that would fall between 2 different parameters, so higher and lower. All right, so later on we'll refer to these as UCL and LCL. So, but right now it's basically getting you used to the idea that, okay, with a bell-shaped distribution, most of the observations are in the middle. Okay, and so if you have something that's too high or too low or too far away from the mean based upon standard deviation, okay, that observation becomes much more unlikely to occur, or it becomes more rare within the data set. And that's all that statistics really does, is we look at Data with descriptive statistics, we try and describe it. Everything else bounding on that, when we're talking about inferential statistics, really the question is like, is there something rare about our data? Okay, and so that's what both of these do. So Chebyshev's theorem uses an actual formula, the theorem here, which is pretty straightforward. It's just 100 times 1 minus 1 over k squared. K is the number of standard deviations away from the mean. Okay, so you can do it using this formula. The only reason why it's a real pain with these problems is because there's one particular problem they do tend to throw at you that requires you to actually do some pretty onerous math in order to get this thing to work. All right, and so I've made life a little bit easier for you in terms of building a spreadsheet that you can use. Now, you only use the spreadsheet on the problems where it says Chebyshev's theorem, okay? These other ones, you can basically do them in your head, because rather than using Chebyshev's theorem, we're going to be using something called the empirical rule. And this is the empirical rule right here. It's very straightforward. States that approximately 68% of measurements in a bell-shaped distribution lie within 1 standard deviation of the mean. So notice this. This is mu minus 1 standard deviation. So mu is our mean. Sigma is our standard deviation. That's going to be our symbol for standard deviation from now on when we're dealing with a population. Later on with samples, it'll be S. Don't worry about that right now. Okay, and so 68% of our observations will occur between 1 standard deviation below the mean and 1 standard deviation above the mean. And so this here is a number line, and so the standard deviation is just the distance between 1 standard deviation and the mean. And so if we take, a look at this, it makes sense because this is where the hump is the highest. And so 68% of our observations are going to fall between this point and this point. 95% are going to fall between this point and this point, which is 2 standard deviations away from the mean, and 99.7% is going to fall within 3 standard deviations away from the mean. Now, if I'm losing you already, it's okay. This is actually way easier than it looks, which makes these problems here where it says bell shape much easier to do, all right? Which is why I use the spreadsheet for these and use math for these, all right? So let's jump in and do some here. Here we go. All right. So Chebyshev's theorem, what you're going to want to do is head on over to course modules, go to descriptive statistics, and grab this guy right here, Cheby's calculator. Download that. Or, I mean, you can do this stuff by hand too. It's not hard. It's just, I think that I built the calculator at the request of students because it does help with these problems. But you have to understand what you're looking for. This is actually 4 separate calculators here. So this is a calculator, this is a calculator, this is a calculator, and this is a calculator, okay? So each one of these corresponds to a different type of problem that you're going to get, okay? And again, the reason why I built this is we're never going to use Chebyshev's theorem again, all right? Chebyshev's theorem is less precise than the empirical rule. And honestly, in the future, if we have data that's skewed in one way or another, we would actually modify the data so that we could use the empirical rule as opposed to using Chebyshev's theorem. So I don't mind if you use this calculator at all. Okay, so you won't see this again. All right, but each one of these calculators corresponds to a different problem. And so let's go back over here to Alex and take a look at our problem. And let me just pull up the calculator here so it's off to the side so you can see what we're doing. Okay, so according to Chebyshev's theorem, at least, and you click on this, it's asking for a percent, okay? What percent of the fares lie between $18.44 and $38.28? So when we're using the calculator, all right, so we have to take a look at the information that it gives us and what it's asking for. And so this one right here at the top, when you have the standard deviation and you're looking for percent, the things in the yellow boxes, those are the things that you have to enter from the problem, and your answers will come out in the gray boxes right here. And so this one, it does give us the upper and lower, so 38 and 1844. And so we would enter that here because we're looking for the percent. It does not give us the percent. We're looking for the percent. And so we want to use this first calculator here for this one. And so let's go ahead and enter all the data. The thing that it's going to ask us for is a population mean and the population standard deviation. Well, here's my mean and my standard deviation. The problem will give those to you most of the time. So we just enter in here 28.36 and hit enter after this so it updates. And then $44.96 is my standard deviation. My upper limit here is $38.28. And my lower limit is $18.44. And honestly, if you just enter one of them, it will still calculate it for you. Just enter the second one just to make sure that nothing's broken in there. And so probability will be 75%, which makes sense. So think about it. This is my mean, 28. All right, so 18 is lower than my mean. 38 is higher than my mean. My standard deviation is 4.96. So this is about 3 standard deviations. It's about 2 standard deviations away from that. And this is about 2 standard deviations away from that. Yeah, so yeah, most of my observations are going to fall between those two. Okay, next one here. Let's take a look at it. According to Chebyshev's theorem, it's at least 36% of the fares lie between what dollars and what dollars. Okay, so this one, I have the percent, but I'm looking for the upper and lower. And so that would be this calculator right here when I have percent and are looking for the upper and lower. And so I'm looking for 36%. So enter this as a decimal, and same thing. We're just going to enter the mean again, 28.36, and the standard deviation, which is 4.96. Okay, upper limit, lower limit right there. And so my lower limit is going to be what? 34.56. Oh no, do this. Make sure you got multiple windows open. You're doing this right. Let me go kick this over here to my other screen so it doesn't get jacked up. All right. So $34.56, and then my upper limit. Oh no, that's backwards. Sorry. So make sure you do your lower first. 22.16, and my upper. Oh, I'm on the wrong one here. There we go. So 22.16 and 34.56. Okay, and so notice that those might line up with these right here. Okay, so experiment with the calculator a little bit, use it. So these are the 4 different types of problems that you'll see on there. Probably when we do more here in just a couple minutes, we'll get a couple of the different ones, but this calculator will make your life a lot easier. Now notice if you click on the cells here, okay, it's all this is Chebyshev's formula, exactly in there, exactly as it is in the description, okay? Or theorem. So this is the theorem exactly as it is in the description. It's easier to do it with Excel. It's a little onerous to do with the Microsoft, with the Alex calculator, but you can do it. All right, but you don't have to. Use a spreadsheet. It's going to make your life a lot easier. Okay, so that's what we use the spreadsheet for. Oh, actually, we're going to be using that a bit more, so we'll just go ahead and minimize that here. So whenever you get these ones that say Chebyshev's theorem, use the calculator. All right, for these are easier. Okay, so using the empirical rule, okay, which if you ever get confused on, just click on this and it'll actually give you the empirical rule right there. Okay, so, and you don't, I don't need it, you might, but you'll get used to it pretty quick. And so think about this. Suppose the distribution is bell-shaped. According to the empirical rule, approximately 99.7% of the fares lie between what and what. Okay, so 97%, so 99.7 is 1, 2, 3 standard deviations away from the mean. Does that make sense? Okay, so see that? 99.7, 3 standard deviations below the mean and 3 standard deviations above the mean, with mean, of course, being the middle. So this is actually really easy. All I do is start with my mean right there, 28.36, add a standard deviation, which is 4.96, add another one, and add another one. Okay, bam, there's my upper limit right there. 43.24 because I just added 3 standard deviations to it. Likewise, to get the lower one, we just subtract them. So my mean, again, is 28.36, taken from the problem right here. Subtract one, subtract another, and subtract another. There you go, 13.75. Okay, that's it. That's all you have to do for these. Now, there's other problems in here that require a little bit of logic, but really when it comes down to it, as long as you understand how this thing works right here, you should be home free on these. Okay? So people get confused when they try and use the spreadsheet on these, okay? But again, this is actually 2 problems glued together, which is why so many people get confused on it. So anyway, let's do this one. Suppose the distribution is bell-shaped. So we're going to be using the empirical rule again. According to the empirical rule, approximately what percent of the fares lie between $18.44 and $38.28? Well, this is pretty straightforward as well, because all I have to do is use the empirical rule here, okay? So, and then I'm going to enter one of these values. I can pick either one. I always pick the higher one, okay? And then I'm just going to subtract standard deviations from it until I get to the mean. And so if it's 3 standard deviations, if I subtract 3, then I'll hit my mean. If it's 2 standard deviations away from the mean, then I subtract 2, I'll hit my mean. Let's just find out here real quick. So my high value here is $38.28. $38.28. Let's go ahead and subtract a standard deviation, which is 496. Okay, is that my mean? Nope. Okay, so see, this is 33.32, and my mean is 28.36. So let me subtract another one. There it is, 28.36. That was 2 standard deviations that I subtracted before I hit my mean, and I know that 95% of my observations will fall within 2 standard deviations of the mean. Okay, check. There we go. One of the values in part C is incorrect. I jacked something up in there, so let's go ahead and do this one again. 99.7 is 3 standard deviations away from the mean, so 28.36 plus 4.96 plus 4.96 plus 4.96, right, is 43.24. So that upper one is good. So let's try 28.36 minus 4.96 minus 4.96 minus 4.96. 1348. See, I jacked something up in there. So people get frustrated with that. You didn't do it wrong. You just messed up something in there a little bit. I do it all the time. So, but there you go. All right, so that's one on Chebyshev. Let's do another one here. Okay. All right, so these first 2 ones here are Chebyshev's theorem, so I'm going to want my handy-dandy spreadsheet for this. And then these 2 here are bell-shaped. I'll just use the Alex calculator for those. So here we go. According to Chebyshev's theorem, at least what percent of the relative increase in stock price lie between 0.52 and 1.12? Notice that these are in percents, but these are just values. Okay, and so don't treat these as percent. In fact, I don't like the fact that they have some problems in here where the observations themselves are expressed as a percentage, because it makes it a little bit confusing. Just watch for these. If you get any of these stock price ones, just enter these as your upper and lower limits. Okay, and so my lower limit on this one is 0.52. My upper limit is 1.12. Okay, and then my mean up here is going to be mean relative increase in stock price was 0.82. So with a standard deviation of 0.15. How long was this? Was this over 5 years? If you invested a stock that had a 0.82 mean return over 5 years, you'd be pissed. That is a bad return on a stock. So anyway, hit enter on all these, and ta-da, it's going to give us our actual difference between the two, which is 75%. Most of these you're going to get 75 and 84. All right, every now and then you get this 56, and sometimes you get the 89, but most of them will be one of these 2. All right, so that doesn't mean don't do the math or have Excel do the math for you. It's just, you know, it's the way it is. So this one here, Chebyshev's theorem, at least what percent, so it's looking for percent, and it gives us different uppers and lowers. So this is actually the exact same problem. Okay, it's just going to change the upper and lowers. Okay, and so my lower limit is going to be 0.595, and my upper limit is 1.045. So this one's going to be that 56%. Okay, right there. Okay. All right, and if you get 2 of them that are like this, it's really easy, because you just leave the population mean and standard deviation the same in the calculator. Okay, and so minimize that, and let's do these bell-shaped ones here real quick. So suppose the distribution bell-shaped, according to empirical rule, what percent of the relative increase in the stock price would lie between what and what? And so this one, I'm just going to take this higher one, I'm going to subtract a standard deviation from it until I hit my mean. And then however many standard deviations, I'll know the percent based upon that. So my higher limit is 1.12. My standard deviation on this one was 0.15. So let's subtract 1. Did I hit my mean? Nope. Subtract another one. Did I hit my mean? Nope. I can tell you yes. There we go. Subtract another one. Hit my mean right there. So that was 2 standard deviations. 2 standard deviations is always, boom, 95%. Okay, and again, that's just that rule. The more used you get to this, so 1 standard deviation is 68, 2 is 95, 3 is 99.7. So the sooner you learn that, the sooner, I mean, so many things in this class come together once you get that. All right, distribution is bell-shaped. According to empirical rule, 99.7 relative increase in stock price lie between what and what. Okay, so this one, 99.7, I know that's 3 standard deviations, so I'm going to take my mean, add 3 standard deviations, take my mean, subtract 3 standard deviations. That's the beauty behind the empirical rule. It just makes things so much easier. And so my mean in here is 0.82. Let's add 1, 2, 3 standard deviations, and so my upper limit is going to be 1.27%, And let's do the same thing to find the lower. So take my mean, .82, subtract 1, 2, 3 standard deviations, and there we go. I get .37. So yeah, 99.7, almost all my observations would occur between those 2 points. Ta-da! Uh-oh, hey, look, there it is. Now it's like, dude, Pat, you got to go do your knowledge check. So we won't do that just quite yet. All right, so I must start within 24 hours. Dun, dun, dun. So that just means, I mean, I don't have to start within the next 24 hours. I can do it, a couple days down the road. It just means that the next time that I log into Alex, if I don't log into Alex for another 24 hours, I will have to take the knowledge check. It will make me do it before it'll let me do anything in my pie. So, all right. Well, hope this is making sense. So we're going to do one more. Customary not to start a number with decimal point. Boom, boom, boom. So anyway, whatever. We will do, all right, movie quote time. Here we go. So for a free quiz in the class. Oh my gosh, I got some really old ones in here. This is great. Let's see. Let's see. Oh, this one's great. And if you haven't seen this movie, you have homework. All right, so a boy's best friend is his mother. Who said, well, you don't have to tell me who. Just tell me the movie. That the line, a boy's best friend is his mother. What movie does that come from? Oh my gosh, I haven't seen that in ages. I bet you go catch it out on TCM or something at some point in time. Boy's best friend is his mother. And of course, who got it right last time? Blake, you're out, buddy. So yeah. Boy's best friend is his mother. Yes, good job, Matt. It is Psycho. Excellent. So now be honest with me. Have you actually seen it? You too, Lexi. Have you seen it? All right. So good job, Matt. Yeah, no, you got it. Have you seen the movie, though? I'm curious. So, my best friend really is my mother. See, that's awesome, man. I appreciate that. You know? I hope it's not like it is in the movie. I haven't seen it yet. Yeah, that's okay. So, it's one of those classic ones. It's sometimes you do get... Yeah, okay, good. Yeah, no, I love it, too. It's... There's a few filmmakers out there who, I don't know, there's just something like really nourishing about their films when you watch them. And Hitchcock is definitely one of them. I mean, he's got some movies out there that, he's like 50s creepy too. So, but you got to kind of grade that on a curve a little bit. But, there are certain filmmakers out there that when you watch their movies, you just feel a little bit different. They're good at either making you uncomfortable or poking you into a place that you're not, well, with Psycho in particular, that's a bad metaphor. But, yeah, no, that's okay. And if you don't like that stuff, that's fine too. But that one, and I remember when I was in college is when I got exposed to Hitchcock. I actually did take one of my film studies courses. It was like my cultural requirement or something like that. I can't remember, or maybe as a humanity or something like that. And the whole class was nothing but Hitchcock films, and it was fantastic. I mean, I really got a new appreciation for them, and so ever since then, every now and then TCM will do the Hitchcock classic, or they'll put up his TV show, which was particularly good. And it's just kind of it's like a different level when you don't have all the special effects and things that you can do nowadays. You got to get pretty creative, and so he was certainly very good at that. There's modern guys who are good at that too. So to tell you the truth, yeah, Tarantino's definitely like that. Tarantino pays a lot of homage to Hitchcock, and he I don't know. I mean, so there's a couple of his movies, because he's got, 9 of them now? And I think he said he was going to do 10 and be done or something like that. There's a couple of them in there that I think he should scrub out and make them not count. But what was the last one? The last one was Once Upon a Time in Hollywood. I love that movie. That movie was fantastic. So, yeah, it was absolutely excellent. Yeah, that's okay. If you didn't like it, I totally appreciate that too. So it's okay. Anyway, back to Chevy Chev here, and then again, what are you jammed up on? Because we got a little bit of flex time here today. And so if there's any topic that you want me to cover, even if it's in the reds, which I'll dive into next week, you know, throw it up there. We'll definitely get into it today because this one, I'm only going to do one more of these. But again, Chebyshev's theorem, remember, if it says Chebyshev on it like this, use the spreadsheet found in Module 2 folder. If it says bell shape, you're just going to use the empirical rule, okay? And so let's do the Chebyshev ones first. And you don't even have to read the problems on these, okay? The only information that you need to pick out is, of course, the standard deviation, or I mean the mean, which it's always got a link to it, and the standard deviation, which it also has in there. So you should understand what both of these are by now, okay? And so here we go. Let's just do Chebyshev. Where's my... Oh, there we go. Oh, God dang it. There we go. So, according to Chebyshev's theorem, at least what percent of the commute lies between what and what? And I got two of those in a row, so I can just use the same calculator on both. And so let me put in my mean and my standard deviation. My mean is 17.5. My standard deviation is 3.3. Okay, upper limit on this one is 24.1. And the lower limit on this one is 10.9. Okay, so 75% on that one. And so this one right here, notice that these two values are higher. This one here, 25.75, is higher. And this one here is a little bit lower. And so I'm not even going to calculate this one. I'm just going to guess on it. So actually, no, let's do the calculations. But that should make a little bit of sense. Since this one's a little bit higher than that and this one's a little bit lower than that, you should capture more of the data. Okay, so but let's just go ahead. Since we got the calculator up, we might as well punch it in. So 25.75 and 9.25 is 84%. See? So after a little while, you kind of get the hang of these. All right, so that's all we need that guy for. Let's go ahead and do the empirical rule runs right here. Distribution is bell-shaped. And everything from this point on time on, we will assume normal distribution with the data that we're working with. So you're going to use the empirical rule a lot. All right, from this point on. All right, distribution is bell-shaped. According to the empirical rule, what percent of the commute lies between 10.9 and 24.1? So I got one of these where it's looking for the percent. So I just start with my highest one, 24.1. Let's subtract the standard deviation until we find our mean. Our mean is 17.5, 20.8. Nope. So let's do another one, which was what, 3.3? There we go, 3.3. 17.5, bingo, there it is. That was two standard deviations. And so two standard deviations, always 95%. Okay. Next one, according to empirical rule, 99.7 of the commute lies between what and what. So remember, 99.7, three standard deviations, 1, 2, 3 up, and then 1, 2, 3 down. So really easy breezy. Just take my mean on this one, which is 17.5, add a standard deviation, add a standard deviation, add a standard deviation. There's my upper, so 27.4. And then do the same thing with the lower. So, except for just going to move backwards, 17.5. Subtract the standard deviation, subtract the standard deviation, and subtract the standard deviation. There we go, 7.6. Which should make sense. All right, so bell shape, 99.7. Most of the data is going to, fit between these 2 points. If that's my mean, yeah, okay. So most of your data will... It's what we call regressing to the mean. So it will actually aggregate around the mean. The more data that you add, the more accurate your mean will be. Check. There we go. All right, so that's Chebyshev in a nutshell. Hope that helps. What else do we need help with? Nothing? Otherwise, maybe we'll go pick something rando here. So, pie slice complete. Ta-da! Continue it's time for my knowledge check. No! See, within 24 hours I can still avoid it, but I will have to do that before Monday. Otherwise, I won't be able to show you anything on Monday, and we'll just have to, I don't know, play trivia or something. No, I'll do it. Good, I'm glad that helped. So, yeah, no, those problems aren't as hard as they look. Just use the calculator. So the Chebyshev calculator that I built that by student request a couple years ago. Just because there is one problem in there, and actually we didn't run into it today, but it's the one where it gives you the number of standard deviations away from the mean, then you have to figure out the percentages. That one's really hard to do in the Alex calculator using Chebyshev theorem. So you have to divide by 1 several times. It sucks. Okay? At least I think that's the one. We didn't run into it today, but I built a calculator specifically so that you don't have to run into that problem because people would get frustrated on it. Other than that, all you're doing is the actual theorem right there. Calculator just makes sure that you're entering it. I mean, the spreadsheet just makes sure that you're doing it right. Okay? And yeah, if you get gemmed up on anything on the spreadsheet, like if you jack up anything, any of the formulas in there, just close it out, download it again. Or, yeah, close it out, don't hit save, and then open it again, and it should come back just fine. Or just delete that one and then download a fresh one, okay? Because sometimes people do jack up the formulas in there. Just make sure that when you enter things in the yellow boxes, you hit enter at the end. If you just use your arrow keys, sometimes it doesn't bite, depending on the version of Excel that you're using. So, good. Glad that helped. All right. So, anything else? Let's go see if we got something rando out here. Probability, we can do a probability one. Here real quick. Factorials. I want to save factorials for next week because we usually start in probability with factorials, combinations, and permutations. There's a calculator that I want you to use for that. And if you have a stats calculator from previous course, those are way easier than if you're doing them by hand. Factorials just take a little bit of time to explain if you've never seen them before. This one's actually pretty easy. So let's do this one. Relative frequencies in a contingency table. Here we go. Or actually, no. Is this the one with coin flips? Let's do this one. This one's great. So this one's really easy. You can crush this one out real fast. All right. So outcomes and event probability. Once we move into the reds, we're going to be dealing with probability. And probability, the law of probability is the thing that governs all of statistics. Basically. I mean, there's other ones too. But probability is a really important one. So the law of probability is really straightforward. It's just the probability of any event occurring is the number of times the event will occur over the number of times the event can occur. Okay, so it's desired possible outcomes over total possible outcomes. And so think about that. It's like coin flips. Okay, coin flip, I want a heads. All right, so heads is one of 2 possibilities because the coin has heads and tails. Okay, so I want to draw an ace out of a deck of cards. All right, so my chances of that is 1 out of 13. Okay, because there's 4 aces, okay, in the deck of 52 cards. You divide that out, it's 1 out of 13. Okay, and so that's the law of probability. That's the way that it works. The reason why we use probability and statistics so much is because that entire bell-shaped distribution we were just talking about. So the law of probability will tell us whether or not an outcome, a particular observation within our data set is particularly rare. Also in the future, it'll tell us whether or not our data set, say like our sample 1, is different from sample 2. Okay, the law of probability governs all of inferential statistics in that respect. Okay, it'll make more sense when we get down the road, but we're going to be doing a lot of things with probability. This is the easiest probability problem, I think, in the entire thing. Okay, because all it is number of outcomes over total possible outcomes. Okay, desired outcomes over total possible. Okay, and so you get these different ones in here. So we have odds and evens, blah, blah, blah. You don't really need to read this stuff. You can just jump into these problems. They're pretty straightforward. Okay, so a number cube is rolled 3 times. A number cube, I don't know why we don't call it a die. Ooh, I bet you there's an interesting reason behind that. Because you don't play number cubes. So, yeah, I don't know. So an outcome is represented by a string of the sort OEE, meaning odd number on the first roll, even number on the second roll, and an even number on the third roll. So it'd be OEE. 8 outcomes are listed in the table below. Know that each outcome has the same probability. Ignore this, okay? What that means is basically each one of these has the same probability of occurring on any given chance, okay? A lot of people get screwed up on this and they just put these in the same. Don't do that, okay? So anyway, so for each of the 3 events in the table, check the outcomes that are contained in the event. Then in the last column, enter the probability, okay? So yes, ignore this, okay? It means by column, not by row. All right. So anyway, event A, an even number on the first roll or the third roll or both. Okay. So we want an E on the first or the third or both. So this one has an E on the first, not this one. This one has an E on the third roll, so check that one. So I'm just looking if there's an E on the front or the back here. Nope. Yep. 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 And yep. Okay. And so count these up. 1, 2, 3, 4, 5, 6 out of 8. Okay, it gives us a probability of 3 out of 4. Does that make sense? So it'd be 6 over 8, reduce the fraction down to 3 over 4. So let's try it again. More even numbers than odds. So we want more E's than O's. Not this one, not this one, not this one. This one has more E's than O's. This one has more E's. This one, nope. This one, yes. This one, yes. So that's 4 out of 8, which is the same as 1 over 2, or 1/2. Okay, an even number on the first roll, so just if there's an E in the first part. Bam, that guy, that one, and that one. So which is also 1/2. Okay, so which makes sense. I mean, if you think about it, the first one's going to have 50-50 chance of that happening. So yeah, okay. Check. There we go. Easy breezy. Let's do one more. Okay, this is coins with heads and tails. And so I'm not even going to read it. We'll just go through it. A tail on the first toss. So we want a T in the front. So 1, 2, 3, 4. So 4 out of 8 is 1 out of 2. Oops. 1 over 2. More heads than tails. So there's more H's. That one has more H's. That one has more H's. That one has more H's. And that one has more H's. So 1 out of 2. And then a head on each of the first 2. So I want HH. So that one, yes. And that one, yes. So there's just 2 of those. And so that would be 1 out of 4. Check. Oops, which one did I check up? B is wrong. Oh, yeah, look at that. I didn't check one of these. More heads than tails. More tails than heads. I forgot to check that one. Yes, it should be the same, though. Oh, boo! What did I jack up? Tails, 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 tails. More tails than heads. 1 out of 2. Which one did I screw up? I thought it said it was the second one. Lame. Let's try it again. So here we go. An even number on the first or last roll. An even number on the last roll or the second roll. So E on number 2 or number 3 or both. So that one, that one, that one, that one, that one, that one, that one. Yeah, so 1, 2, 3, 4. 1, 2, 3, 4, 5, right? On the last roll or the second roll or both. So that one too. So yeah, 3 out of 4. Okay. Odd number on each of the last 2 rolls. So 2 O's. 2 O's. We just have 2 of those. So that'd be 1 out of 4. Right? Yeah, because it'd be 2 8s. Yeah. Oh. More even. So more E's than O's. So more E's. More E's. Oops. More E's. More E's. So that's 1 out of 2. Check. Now I'm like second guessing myself because usually these are really easy. So anyway, heads and tails. A head on each of the last 2. So a head on the last 2. On each of the last 2. So head, 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 head. There's just 2 of those. 1 out of 4. No heads on the last 2 tosses. So TT on the last 2. So that one and that one. Yeah, it would be the same, just inverse of the previous one. Okay, more heads than tails. So more H's than T's. That one and that one. 1, 2, 3, 4. 1 out of 2. Yeah, check. Alright, cool. Let's do one more here. I don't know what I jacked up on that last one. Probably something silly. A tail on the second toss. So a T in the middle. Bam, 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 and bam. So it should be half of them. Because, of course, probability of getting a T on any half toss would be 1 out of 2. Alternating head and tail and head. So alternating. So nothing in order. That one and that one. So just 2 of those. 1 out of 4. Tail on both the first and last tosses. So a T on either end. That one and that one. That's it. Tail, right? Not head. 1 out of 4. Alright, check. Donezo. Alright, cool. Alright, there we go. That's probability for us today. So, yeah, we're going to wrap up a little bit early today unless you have a question. So if you have a particular topic that you're jacked up on and you need some help with, punch it in there. Otherwise, we'll do one more movie quote question here and call it a day. Get you guys headed on towards your weekend. And the absolutely wonderful weather forecast. Oh, I could ask you, you're going to need a bigger boat, but you all know that one. Yeah. Let's see. Let's see if they got anything in here that's a little bit more recent. Let's see. Oh, this is great. Yeah, I just watched this one too, not lately, not too long ago. Whenever this movie is on TV, I will watch it. So it's I Drink Your Milkshake. What movie did that come from? I Drink Your Milkshake. That one's excellent. You're just talking about really good movies. That one is fantastic. I Drink Your Milkshake. What does it come from? Go. And who's eliminated? Yeah, let's see. Matt got it and Blake got it. So Lexi, now's your chance. Guts, get in there. So, yep. There Will Be Blood. You nailed it, Lexi. That one is fantastic. So I love that movie. Yeah, Daniel Day-Lewis is one of those guys, whenever he pops up in a movie, he just automatically gets my attention. And that movie, I have watched that one, at least 3 or 4 times, and I still don't quite get the entire thing. That's true of the other one. What's the other one that... it's got Josh Brolin in it, and oh my gosh, I can't think of it right off the top. It's got Josh Brolin and Tommy Lee Jones in it. It came out right about the same time. Blood, oil, blood. Yeah, I know. yeah. So I'm thinking about the other one right now too. So what the heck is it? So, shoot. Yeah, whenever that one pops up, I watch it too. Even though that's much scary. It's got Woody Harrelson in it too. It's No Country for Old Men. There we go. Whenever that movie's on, I watch that one too. So there we go. All right. So all right, good job. Good work this week, guys. If you have any questions, I'll stick around here for another minute or two, just in case you want me to cover a topic in private or something like that. Again, no word yet on. Well, there. It looks like we will be going back to school, but at least not for another week or so. And so I'm waiting to see what kind of news pops out on that this weekend. But for right now, next week we're absolutely going to keep doing this. So I hope to see you all again back on Monday. Back here on YouTube on Monday, that is. So, but at the same point in time, enjoy the weekend. I know it's going to be cold, but, it'd be a great movie weekend. So get out there and check out some movies. Email me if you got one today, and I will hook you up here. In fact, I'll clean those up here. I got a class coming up, but I'll try and get to them here real quick. So, but at the same point in time, good job. Keep up with Alex, and if you're on pace with me, you're doing great. And like I said, have a good weekend. Feel free to log off now, but I'll stick around just for a couple more minutes if you need anything. Other than that, enjoy, take care, and we'll catch you all next week. You bet, Jake. So, no worries, Aiden. You too. Take care. You too, Lexi. Go ahead and get out of this. Yeah, I'm going to have to go watch that movie again. I think that milkshake line is right before he beats him to death with the bowling pins. Yeah. All right, 10 seconds here. If you got any questions, punch them in. 5, 4, 3, 2, 1. Dunzo. See ya.